Hi everyone! In this video, we're going to talk about reflections. So a reflection is a transformation across a line when we flip a shape over a line. And there is four main lines that we use, the x-axis and the y-axis, and the lines y equals x and y equals negative x. And then we could also do it on any vertical or horizontal line that we wanted. If we wanted to write it in transformation notation, we would use a lowercase r, and then the subscript would be the line that we are reflecting over, and then the point that we want to reflect. In coordinate notation, if we're using one of our specific lines, we do have a rule that we can use. I'll also show you how to do this graphically. In this image, or in this diagram, we have trapezoid LMNO, and the image of that trapezoid, L prime, M prime, N prime, O prime. And visually, you can see that the trapezoid was reflected over this line. This is my x-axis. And let's look at our coordinates. If we notice our y values, I went from 5 to negative 5. I went from 5 to negative 5. 1 to negative 1, and 1 to negative 1. Each time, we notice that the y coordinates are changing sign. Which makes sense. If we look at what's happening to the point is changing along our y-axis. It's going from the positive y-axis to the negative y-axis. Now, what do you think would happen if we were to flip the quadrilateral over the y-axis instead of the x-axis? We can even sketch that out. If I were to flip it over the y-axis, I would just count how many units I went to the y-axis. So in this case, it was 1, 2. Then I would go 2 more. Point M, you notice, wouldn't move because it is on that axis. Point L, I would go 1, 2, 3, 4, 5, 6, 7. So I could go 7 on the other side. 1, 2, 3, 4, 5, 6, 7. And then O is going to be right here. And so if we notice our coordinates, the y values have stayed the same, but our x values, the x values are changing sign. So when we reflect over the y-axis, our x values are going to change the sign, which is what is listed right here. This negative is telling me I'm changing the sign of that value. Let's also look at this diagram right here. They want us to draw the line y equals x. As a refresher, y equals x is actually the line y equals 1x plus 0, right? Plus 0, so the 0 disappears, and we don't normally write a coefficient of 1. So in this case, my slope is positive 1, which would also be known as 1 over 1, and my y-intercept is 0. So if I wanted to graph my line, I would start at my y-intercept. I would go up 1 over 1, up 1 over 1. And we're getting this line that has a slope of 1 and starts at our origin. So it kind of cuts our coordinate grid diagonally in half. And if we reflect over the line y equals x, you notice I could go just 2 coordinates this way, so I'm going to go 2 more. This would be b prime. A would go 1, 2, 3, 4, or 3.5, so half, 2.5, 1.5, 2.5, 3.5. And then C would be over here. But you might also notice that doing it graphically is not the easiest because you have to go on a diagonal, which doesn't always work super nicely. So instead, we could look at our coordinates. When we reflect over the line y equals x, we're going to switch our coordinates. So instead of -2, 5, it would be 5, -2. Instead of -2, 2, it would be 2, -2. You notice that I am switching. This would be 2, -5. So we are switching the x and y. We're interchanging the x and the y. Now, if we were reflecting over the line y equals -x, y equals -x has a slope of -1, so it would look like this. In that case, we are going to have to switch the values and change their sign because of the negative. And that is listed in this rule right here. So you see for y equals x, we just switch the position. For y equals -x, we switch the position and change the sign of them. Our last step is, well, what if we had any other line? What if we had a vertical line, which would be a line in the form of x equals some number, right? Because I'm going to intersect my x-axis and go up and go down. Horizontal lines would be y equals some number, where you're going to put the point at your y-axis and then just go to the left and the right. We can also do reflections over these lines. So to start this problem off, I'm going to graph triangle PQR. So -2, +3 is point P. And you notice I'm labeling my points every time. Q is 2, +4. And R is 1, -1. And if I connect these points carefully, it'll look like this. And then they want us to reflect PQR over the line x equals -3. So the first thing that I notice is it's an x equals. So x equals tells me it will be a vertical line. So I'm going to go to -3 on my graph, and I'm going to draw a vertical line up. I would suggest that you use a ruler for something like this, and then I'm going to draw my vertical line down. So this is my line, x equals -3. To do a reflection, and you can do this over any line, but especially one where there's not an easy coordinate rule, what I'm going to do is I'm just going to count the number of spaces to my line of reflection, and then I'm going to go that number of spaces over. So in this case, P was 1 unit away, so I go 1 unit on the other side, and that is P prime. For Q, it's 1, 2, 3, 4, 5 units. So I'm going to go 1, 2, 3, 4, 5 units, and there's going to be Q prime. R is 4 units away, so I'm going to go 4 on the other side, and there is R prime. And then I can connect my points, and we reflected it over a different line. I can also then record the points for P prime, P prime, Q prime, and R prime. If I want to record those coordinates, P prime is going to be 1, 2, 3, 4, up 3, so it would be -4, 3. R prime is -7, -1. And then Q prime is up 4 and over 8, so -8, +4. So in this case, all I did was count my number of units, which you notice is the same thing that I actually did on this diagonal problem. We could also do it here, right? This is 1 unit away, so I'm going to go 1 unit on the other side. This was 2 units here, so I went 2 units on the other side. I'm just counting to my line that I am reflecting over and plotting my new point. And that is how we do reflections over a variety of lines.